Hi, I'm Jessica here at Nautilus Mission Control at the Inner Space Center in Rhode Island. And we're joined today by the Chief Scientist for Leg 6 of the expedition, Jeff Karson, who's currently in the studio on the Nautilus. So welcome, Jeff. Thank you so much for joining us today. And I wanted to start off by asking you, we're off the coast of Portugal. Why are we in this area and why is it so scientifically interesting?
We're about 150 nautical miles west of Portugal, out in the eastern part of the Atlantic Ocean, at a huge mountain on top of a ridge called Orange Bank. The mountain is called Gettysburg Seamount. Now there are many seamounts all throughout the ocean basins, thousands of them, but almost all of them are volcanic in origin. That is, they're basically big volcanoes. Some are active and most of them are extinct. This particular seamount, though, is a huge block of crust that's been uplifted and, in fact, even at one time was above sea level and somewhat eroded off at the top. The rocks there inside the mountain that make up that mountain are really not crustal rocks at all, but in fact they're parts of the Earth's mantle. The mantle makes up about 81% by volume of the planet, but it very seldom peaks above the crust anywhere.
So why is it so interesting that this mantle rock is coming up at this specific site?
About 10 years ago, in an investigation on the Mid-Atlantic Ridge, we discovered a place called the Lost City. It was on top of a mountain of mantle rock, very much like Gettysburg Seamount, and it's a place where seawater and that mantle rock interacted in a reaction called serpentinization. Basically, it's a reaction in which water is added to the crystalline structure of that mantle rock. It gives off heat, it causes the rocks to swell, and it causes some very peculiar chemical changes to the fluids. Up to that point, we thought that all hydrothermal vents were located on mid-ocean ridge spreading centers and were fueled by magmatic heat. Here was a place that was way off the ridge axis, and it was circulating away, supporting exotic life forms, and it was in relatively old, cold rocks far away from the ridge axis. Gettysburg Seamount is my best guess for a place that's way off the ridge axis where this process could still be going on.
So why would it be particularly exciting to find these kinds of vents at Gettysburg Seamount?
To begin with, any hydrothermal vents on the seafloor are pretty exciting features because they support such strange life forms and because we think of them as really good analogs for the way life forms could exist on other planetary objects. Because we've only found one of these serpentinization vents, as we call them, at that Lost City site, finding a second one would be extremely interesting. It'd be interesting to see if the ecology of the ecosystems was the same or different, the chemistries, how they would compare, and as I said, this real important significance would be that that would sort of signal to us that hydrothermal venting could be taking place in many, many places on the seafloor.
Well, thank you so much, Jeff, for taking the time to talk to us today.
Thanks, Jessica. It's a pleasure talking with you.
Again, I'm Jessica here at Nautilus Mission Control. Stay tuned at nautiluslive.org. And now back to the action on the ship.